Okay, you're going to find 6, 5 is not going to be too much different from 6, 4. So 6, 5 says if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So again, I know I have a parallelogram, so I know that the opposite sides are parallel. So it says if I know that these diagonals are perpendicular, then it's a rhombus. Okay? 617 says if the diagonals of a parallelogram bisect a pair of opposite angles, then the parallelogram is a rhombus. So again, if I know I have a parallelogram and I know the diagonals bisect a pair of opposite angles, then I know it's a rhombus. This one says the diagonals of a parallelogram are, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So if, again, first of all, it is a parallelogram. So if the diagonals, we'll label this one too. So if these diagonals, so if AC is congruent to BD, then it's a rectangle. All right, it's P1 and P2. So P1 says, what can you say about these parallelograms? So in this, you already know that they're parallelograms. In this one right here, we can see that these angles are all congruent. So if the diagonals are parallel and bisect a pair of opposite angles, then the parallelogram is a rhombus. So this is a rhombus because of that theorem 617. This one right here, so I know again that it's a parallelogram. I can see here that the diagonals are perpendicular, so that tells me it's a rhombus. So I know it's a rhombus from 616, but I can also see that the diagonals are going to be congruent because I know that they bisect each other, but this and this and this and this, so they're all congruent. So then that would also make it a rectangle. So if it is both a rectangle and a rhombus, then it must be a square. Okay? For what values of y is the parallelogram a rectangle? So again, if it's a rectangle, then this whole diagonal and this whole diagonal are congruent. But by being a parallelogram, these pieces are congruent. So basically all these little pieces right here are congruent in that rectangle. So I can just say 5y plus 3 is equal to 7y minus 5, 2y, 8, so y is equal to 4. Okay? So that's 6, 5. 6, 6. So 6, 6 is just moving on to talk about some other trapezoid and a kite. So those are other quadrilaterals that just have a little bit of different properties. So trapezoid is a quadrilateral with exactly one pair of parallel sides. The bases are the parallel sides. The legs are the non-parallel sides. The base angles are the two angles that share a base. So here's my trapezoid. Again, I have exactly one pair of parallel sides. I have these right here, which are the parallel sides of the bases. So here's base, here's the base. The non-parallel sides are the legs. So there's a leg, there's a leg. And then it says, so I'm going to call this 1, 2, 3, 4. It says, actually, just going to switch it up because that's not the way I did it in my other notes. So 1, 2, 3, 4 is how I wrote it in my other notes. So I would say that 1 and 2 are a pair of base angles. And then 3 and 4 are a pair of base angles. All right, an isosceles trapezoid is a trapezoid with legs that are congruent. So again, we got one pair, we got those bases that are parallel, that's the parallel sides, the pair of parallel sides. And then an isosceles trapezoid, the legs would also be congruent. All right, theorem 619. If a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So if we know we have an isosceles trapezoid, then angle 1 would be congruent to angle 2. I mean, the same thing if I had 3 and 4 up there, then 3 and 4 would also be congruent, okay? All right, find the measure of the remaining angles. So what this means in this picture right here, so based on that last theorem, is S is also 106. These lines are parallel, so then the same side interior angles are supplementary. So whatever this angle is, it's supplementary to this angle. But these are base angles right here. This is an isosceles trapezoid, so those would be congruent. So the measure of Q is going to be equal to the measure of P, which is going to equal 74. So theorem 620 says if a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. All right, so just like in that rectangle, those triangles would be, or those diagonals would be congruent. All right, on the back, a midsegment of a trapezoid, just like a midsegment of a triangle. So a midsegment of a trapezoid is a segment that joins the midpoints of the legs. All right, so again, this would have to be a midpoint. Midpoint joins the legs, okay? Trapezoid mixed segment theorem. So if a quadrilateral is a trapezoid, then the midsegment is parallel to the bases, and the length of the midsegment is half the length of the sum of the bases. So what this is saying here is that that midsegment is parallel to each base, and that midsegment, the length of it, is half the sum of the other two bases. Of course, you could also say the midsegment is double the sum of the other two, so that would also work, okay? So using that theorem, so it says Mn is the midsegment of the trapezoid, find x and Mn. So this right here is half those two sides. This ends up being 8x minus 2. You could multiply both sides by 2, or you could distribute the 1/2. These are even numbers, so it's not hard to distribute the 1/2. If they were odd, I probably would multiply both sides by 2. Solving for x. So add 1, subtract 2x, and then x ends up being equal to 6. Plug it back in to find Mn. 2 times 6 plus 11, is going to be equal to 23. Okay? Kite. A kite is a quadrilateral with two pairs of consecutive sides congruent and no opposite sides congruent. It's kind of a funny one. It says consecutive sides, but it has to be those two sides. And then these two sides, like these sides are consecutive, but they're not the congruent sides, okay? If a quadrilateral is a kite, then its diagonals are perpendicular. Again, if, sorry, I'll draw it down here. Again, if I draw in that diagonal, so, and then this right here, it's just saying that these are perpendicular, okay? So down here, when it finds, let's find the measures of the angles. So there's the perpendicular. So the measure of angle 1 is 90. You know this one is 36. 3 is also 36. These two little triangles right here are congruent to each other. So then 2 is just what's left over if I do 180 minus 90 minus the 36. I would get 54. Okay? All right, that is it. You got this one right here, and there's the 6'5" ones.